Welcome and thank you for joining again. Let's take a look at another trig equation. This time we have secant 2x plus 1 over cosine x equals 0, where the unknown angle x is between 0 and pi radians. As you can see here, we have secant and cosine involved in this equation. These are two different trig ratios, but they are related to each other. They are each other's reciprocals. And we have angles double and single x. So we're going to take care of these two problems one at a time. First, we'll replace secant 2x by 1 over cosine 2x. So at least we have cosine in the equation, just cosine. And then the rest of the equation is the same, plus 1 over cos x equals 0. So now we have a new problem. We have fractions throughout the equation, and we have double angles, which we already had before. Now, we're going to take a look of the fractions. Remember that we are in an equation here, and in an equation, as long as we apply the same transformations to both sides, we still create a new equation. And we are going to eliminate the denominators. That's our goal for now. And to eliminate the denominators, we usually shoot them with the lowest common denominator. So the lowest common denominator in this case will be cos 2x cosine x. So we'll multiply by cos 2x cos x every term in the equation. So we'll multiply 1 over cosine 2x by it. And we'll multiply by cos 2x cos x, the second term. And on the right side, we just have 0. We know that multiplying by 0 doesn't change the story about this equation, but we'll show our work in here, so just for courtesy. All right, so now we are going to check and see how the denominators would simplify. So here goes the first denominator, cos 2x, simplified. There goes the second denominator, cosine x, simplified. And the right side didn't have any denominator, so let's rewrite the equation again. So the first term will have just cosine x. The second term will have cosine 2x. And the right side of the equation is still 0. So one small little problem we have to resolve in here. So we have angle double x and single x. And as you recall, we had the formulas for double angle, for cosine ratio, 3 of them. So cos 2x equals, or cos 2 theta, we said, equals cos squared theta minus sine squared theta. That won't help us because we don't want to bring in a new ratio. And then we have 2 cosine squared theta minus 1. Oh, that seems very suitable because then we have just cosine in the equation. So we'll jump onto the opportunity here. We have cosine x plus 2 cosine squared x minus 1 equals 0. So we have created a quadratic equation. So 2 cosine squared x plus 1 cosine x minus 1 equals 0. So if you want to replace cosine of x by a helping variable, we can easily do so. And this will change the equation to be 2a squared, and then plus a, and then minus 1 equals 0. Let's try to factor. It seems to be factorable. So we have 2a and a, and two numbers that multiply to negative 1, but we still have the sum of 1. The numbers we need to place in here are the, let's say, plus 1 here, negative 1 here. So 2a minus 1 equals 0 if a equals a half, or a plus 1 is 0 if a equals negative 1. So let's bring cosine x back in. So that means cos x equals a half, or negative 1. So for x, so just simply use the calculator. But if you remember, 1 over 2 is a special cosine ratio, and that would be the cosine ratio of angle 60. So if your calculator gives you 60, write that down, but quickly convert to radians. That would be pi over 3. Draw the angle as soon as you find the value of it. Pi over 3 would be somewhere here. So the other angle with the same cosine is drawn by reflecting the terminal arm about the x-axis. Oops. So here goes pi over 3. And here goes 2 pi less pi over 3. So that means 6 pi over 3 minus 1 pi over 3, 5 pi over 3. So let's move on to our next solution. We have cosine x equals -1 because a was -1. So x would be inverse cos -1. If you use the calculator, then it will probably give you the answer 180 degrees in radians, which in degrees, which in radius we will convert to pi radians. So let's draw the angle. So the pi radian angle will have the terminal arm on the negative x-axis, and there it goes. There is pi. And it seems that this would be our only solution we get here, because if you reflect the terminal arm about the x-axis, it will be the same terminal arm because it's on the reflection line. So here go our 3 solutions then. So we have x equals pi over 3, x equals 5 pi over 3, and x equals pi. Now let's take a look at the graph as well and see where our solutions are located. So what we did in here was type up the equation secant 2x plus 1 over cosine x on Desmos, and this is what it gave us, this very fancy graph. And type up the equation y equals 0, which is the right side of the equation. And here we go, we have the intersection points of y equals 0 with the left side graph at pi over 3, pi, and 7 pi over 4. Oops. 5 pi over 3. Great, so that's the answer. All right, so I hope this made sense again, and thank you for learning with me. Bye for now.